Hello, good evening, guys. Happy Monday. This is our August week 2. Okay, how is everyone doing? Let's finish our light chapter for today first. We have a small part remaining. Okay, so, so guys, do you remember what is reflection, 反射, and your refraction, 折射? These two things. One is the bouncing of light. Okay, the bouncing of light. Uniform reflection, you will see shiny surface. Dull reflection means you see non-uniform reflection. Okay, and then what is refraction? This is the bending of light. Okay, if the light goes from fast to slow, okay, because air, less people, less particle, less dense, fast. Glass, denser, because glass is very packed, so they will go slow. So when they go fast to slow, they will bend in. Okay, fast to slow, they bend in. Slow to fast, they bend out. Okay, I hope you remember this. Okay, today we'll be talking about colors. We'll be talking about light. Okay, guys, give me a moment. Okay, so let's talk about dispersion of light today. Okay, what is dispersion? In Mandarin, this is called 分散. Okay, if you need Mandarin lah. Okay, so what is 分散? What is dispersion? Basically means the dispersion of light when you separate light into its component color. Okay, so it's the dispersion of white light. It's the separation of white light into its component color. So as you know, white color is made up of 7 colors. Okay, which is the rainbow lah. You know this, right, guys? Your white color is made up of Roy G beef. Okay, Roy G beef, red, orange, yellow, green, blue, indigo, violet. So 7 colors. So when you split 7 colors into its component color, sorry, you split white light into 7 colors. So that's what you get. Okay, your Roy G beef. Okay, so this happen. Okay, you might say, sir, isn't this refraction? Okay, 折射, isn't this refraction? Yeah, this is refraction and dispersion. Okay, yes, it refracts, correct, but it also splits the color out. So that's your refraction. Sorry, that's your dispersion. So when you disperse the color out, you see Roy G beef. Okay, so this is how your rainbow form, lor. Nothing to memorize here. Nothing of this what less dense to dense bend in, less dense to less dense bend out. No such thing. Okay, you just need to know the 7 colors. And I think you already know the 7 colors. Anyone here doesn't know rainbow 7 colors? Anyone? If you don't know what's the color of the rainbow, then I worry for you. Okay, so yeah, there you go. Okay, so rainbow happens after rain because the rain is acting like this prism. Okay, prism is the 三棱镜, this thing. So when you have raindrops after raining, so the light, so the sun will go in and then they will disperse the light out and then you will see a rainbow. Okay, guys, if it's humid enough, if it's wet enough, you even see a double rainbow. Have you guys seen a double rainbow before? Okay, and I believe this is kind of a good luck thing. Right? Quite hard to see. I've never seen one in real life before. But double rainbow is when you see 2. So pretty, huh? So it's a very rare occurrence. So rainbow can be seen when rains drizzle. That means you have light rain. When the sun is behind the observer. Okay, the sun needs to be behind you. It's the refraction and reflection. Okay, you create 7 colors. Okay, that's all. Dispersion. Nothing much to say. And then what is colored light? This one I think you should know. Okay, guys, let's talk about filter. Okay, let's talk about filter. Filter will only allow light of its color to pass through. Okay, what does it mean? Okay, if it's a red filter, it only allows red to go through. If it's blue, it only allows blue. If it's green, it only allows green. So can you see RGB here? RGB lah. Okay, should be RGB. Right? RGB is the basic colors. RGB are the basic colors of light. Right? It's the basic color. That means when you have R, G, and B, red, green, and blue, you can make any color you want. Right? I know what you're thinking when you're learning arts, right? when you are having your arts class, the three basic color is completely different. Okay, for arts, when you're learning drawing, things like that, the basic colors are red, yellow, blue. Okay, red, yellow, blue. And you're here asking, sir, why is this RGB? Why is it red, green, and blue? Because red, green, and blue, for this thing, these are the basic colors of light. Light, 光线, when you look at your computer screen, when you look at your whatever screen, your phone screen, the basic colors are RGB. But when it comes to color, pigment, the one you use to color, the basic color is red, yellow, blue. Okay, it's red, yellow, and blue. So RGB, red, yellow, blue. Different, different. We're not talking about arts one. Okay, I'm sure you learned this in primary school one. Red plus yellow is orange. Yellow plus blue is green. Red plus blue is purple. No, we are totally not using that because that is another thing. Okay, completely another thing. So what we want to talk about is the addition of light. Okay, let's talk about this. Can you see three basic color? Can you see RGB? I mean, if you play computer games, you know what is RGB lah. Okay, this is what we care about. Three basic colors. When you have three basic colors add together, you get white. Can you see? When you have RGB together, you get white. This is how your computer screen makes white color. This is how your phone screen makes white color because they have RGB behind. When three they switch on together, you'll see a white screen. Okay, and this is what you need to memorize. Red plus green is yellow. Okay, green plus blue is cyan. Cyan is like a lighter blue. Red plus blue is magenta. Guys, do you recognize these three colors? They are your printer colors. They are your printer colors. You know your printer has cyan, magenta, yellow, right? Okay. Your printer has two cartridges. Okay, one is the black one, and one is the cyan, magenta, yellow, CYM. Okay, CYM, cyan, magenta, yellow, that one. Right? So these are your printer colors, but the basic colors are these three, RGB. Okay, for you, this might make no sense. Okay, you might be like, sir, how can I memorize this? Okay, it's actually very easy. I just remember it as if you go to Mary Brown. Okay, MRB, Mary Brown. You know it's Mary Brown? Mary Brown is a fast food store. Okay, if you go to Mary Brown to eat GCB, you know it's GCB? GCB is a McDonald's burger. Any of you tried GCB before? You know GCB, you know McDonald's has McChicken, Filet-O-Fish, and double cheeseburger, and then you have something called GCB. Spicy chicken McDeluxe, okay? So one of it is GCB. So if you go to Mary Brown to eat GCB, it makes you more gayer. As in more gay. This is how I remember. Okay? Do you need to memorize this? Yes and no, right? Some school they will ask, some schools they won't. But it's not a main thing. It's not a main thing, but it's good to know. All right, it's good to know. So Mary Brown to eat GCB, it makes you gayer. Okay, guys, are you following so far? Are you following so far? Just to check out on your Zhihan, Xinteng, and Yunki. Are you guys okay? Are you guys okay? Can you please give me an okay if you're really okay? Hello, guys. Give me an okay if you're okay. Cool, cool. Okay. So these are your colors. So very different, isn't it? Okay, very different. Okay, let's talk about absorption and reflection of light. Okay, I think this is more important and this makes more sense. Okay, this makes more sense. Right, guys. If you see a red color t-shirt, why is it red? Okay, this is a funny question, isn't it? When you see a red color t-shirt, why is it red? Because red is the only color they don't absorb. Are you getting what I'm trying to say here? Okay, if let's say I wear a red color shirt, if I have a red color shirt, white color come to my shirt, the white color will be absorbed by my shirt. So white color is made out of 7 colors, right? My red shirt will absorb orange, yellow, green, blue, indigo, violet, but my shirt will not absorb red. So the red will bounce off my shirt. That's why I see the shirt as red. Right? So whatever object that is that color It is that color because the color is reflected to my eyes. If you get what I'm trying to say. Okay, so for example, if let's say you have a plant, so your plant is green. Okay, your plant is green. So when you shine a white light to it, you see red, orange, yellow, green, blue, indigo, violet, you shine 7 lights to it. Green is the only color they don't absorb. They don't absorb green. They absorb other 6, but they don't absorb green. So the green will bounce off to your eye. The green will bounce off to your eye. So you see green, right? A green object only reflects green light. They don't absorb green light. Other color objects, other colored lights will be absorbed. Therefore, the object appears green. I absorb all 6 colors. I will bounce off green. That's why I see green. Okay, it goes for everything. Why is the blue shirt blue? Because the shirt doesn't absorb blue. Why is the purple shirt purple? Because the shirt doesn't absorb purple. Right? Why is what else? Why is an orange looks orange? Because orange is the color they don't absorb. They bounce off to our eyes, we see orange. Right? What about white? What about white? White object, they absorb no color. They reflect everything. That's why white color shirt, they don't absorb heat. You see, if you're standing under the sun, if you wear white shirt, you are fine because white shirt won't absorb anything. But black shirt is totally different. Black shirt will absorb everything, right? Black shirt will absorb everything. No light is bounced off. That's why you see no color. When you see no color, you see black. Black is the absence of colors. You get what I mean? If there's no color, then you see black. So why is my, okay, I'm wearing a black shirt today, you see? Why is my shirt black? Because my shirt doesn't absorb, and sorry, my shirt will absorb everything. That's why if you wear black shirt under the sun, it's so hot. Okay, it's so hot because your black color shirt absorbs everything. So your shirt gets hot. Oh. Your shirt gets your black shirt gets really hot. Guys, have you tried black shirt under the sun? Okay, or you do it this way. You stand under the sun for a few minutes, then you touch your hair, you feel it really hot. That's the reason why. Okay, because your hair is black, it will absorb all the heat and it feels hot. Okay, so guys, that's for your color. That's for your color. I'm not going too much into your color because it's something really simple. Okay, so we do the remaining of the exercise, shall we? Let's go to number 5. Okay, let's go to question number 5. Okay, question number 5. So the photo below shows the formation of a rainbow. Okay, so this is a rainbow. Which light phenomenon or concept is this situation related to? Explain briefly how the rainbow is formed by this concept. Okay, so what is this phenomenon called? This is called the dispersion of light. Okay, 光线的分散, dispersion of light. So, how is this formed? Okay, so you have raindrops in air. Okay, raindrops in air, so it will disperse sunlight into its component colors. Okay, it will disperse your sunlight into component colors, and you have 7 colors. Okay, 7 colors. So this is how dispersion works. Right, this is how dispersion works. So number 6, so you have 3 color lights here. You have RGB, 1 primary color and 1 secondary color. Oh, I forgot to mention what is primary color. Guys, if you learn arts, you know this. The basic colors are called primary colors. The color that you cannot get by mixing. Like when you learn arts, red, yellow, and blue is your primary color because you cannot get red color by mixing any other color. They are the basic color. We call it primary color. So your primary color is going to be your RGB. Okay, your red, green, blue. And then your secondary color is going to be your cyan, magenta, yellow. Okay, cyan, magenta, yellow. Of course, in arts, our secondary color is orange, green, and purple. There's no such thing here. Okay, so that's your RGB and CYM, CMY, whatever. What is meant by primary color? Okay, I just said it. Okay, colors that cannot be obtained by mixing other colors. All right, it is the basic color. So what is the color of region Q? Like I said, this is Mary Brown goes to, you go to Mary Brown to eat GCB, it makes you gayer. Okay, so your red and blue, you get magenta. Right? Guys, take note that this color part is not really that common. I'm not saying that it's not coming out, but it's not very common. So, if you want, you focus, right? I mean, it's not very hard to memorize, isn't it? So, right, the color produced when the lights are mixed, okay, RB. So you have Mary Brown, magenta, Mary Brown. Red and green, this is your gayer, GYR, yellow, gayer. And then you have GCB, cyan, GCB. So 3 colors, you get white. Okay, 3 colors, you get white. Okay, so that's it. Okay, this color part is really simple. Okay, next, number 7. Oh, this is a very good question. Okay, so figure below shows a student wearing a t-shirt and blue shorts standing under a yellow light. Okay, yellow light, this is not white light, white light has 7 colors. Now yellow light is only, okay guys, yellow light is a secondary color. So please split this into 2 first. Yellow is made from gayer, so green and red. Green and red, you get yellow light. Why split this? Why split this? Guys, whenever you see secondary color, split them into 2. Because easier for you to see. So what are the components of yellow light? They're asking it already. Yellow light is made from green and red. Okay, green and red, because gayer, GYR, if you remember. So B, what colored light is reflected by the red t-shirt under white light? Okay, white light first. They ask for white light first. You see, why is a red shirt red? Because red is the only color they reflect. You get what I mean? If I'm wearing a red shirt right now, you will see red because red is the color it doesn't absorb. Hope I'm making sense here. I look red because I don't absorb red. If it makes any sense. Okay, I am red because I don't absorb red. I bounce off red, that's why you see me red. Okay, so same thing here. Red shirt will look red under white light because it bounces off red light. So see, what are the colored lights that are reflected by the t-shirt and shorts under yellow light? Now it's yellow light. You see, yellow light. Okay, let's look at the shirt first. Okay, so now just now white light has 7 colors, right? White light has 7 colors, but now yellow light only has 2 colors. Yellow light, there's only green and red. Okay, yellow light, there's only green and red. So you see, when green, okay, let's talk about green first. When green comes to the shirt, you see the shirt is red, right? That means red is the color they don't absorb. Red t-shirt doesn't absorb red, if it makes any sense. So yellow will come, sorry, green will come. Green will be absorbed by the red light, by the red t-shirt, because red only doesn't absorb red. But when red comes, I see red here. When red comes here, red will be bounced off. Red comes here, red bounce off, right? So the shirt will look red. Okay, green and red comes, green will be absorbed, red will bounce off. Are you guys okay with what I'm saying here? I know this is a bit hard. Okay, so what about the shorts? Okay, short is blue. The short is blue. Blue only doesn't absorb blue because blue is a primary color. That means a blue shorts will look blue because they bounce off blue. They don't absorb blue. The rest they will absorb. So can they absorb green? Yes. Can they absorb red? Yes. So both colors will be absorbed by the blue short. Then sir, no color reflected wall. No color reflected wall. How? Then you see black wall. Okay. If you shine a yellow light onto a blue short, you will not see any color. The blue shot will look black. I know it makes no sense here. I know it makes no sense here, but this is how it works. Yellow is made from green and red. The blue shot will absorb both colors. Green and red will be absorbed by blue because there's no blue here. You see, if there's blue here, the blue will bounce off. Then you will see the pens as blue. But no, there's no blue here. There's no blue here. There's only green and red. So the shots will absorb both colors. Okay, the shots will absorb both colors. So you see black. When both colors are absorbed, you see black. Okay, so what is the color of the student's hair under yellow light? For confirm black lah, because hair is already black man. Black means they absorb everything. No need to care. Whatever color you give them, they look black. So explain your answer in D1. Okay, how do you explain this? Oh, sorry, there's a typo here. Okay, D1 should be here. Why is the color? Why is the hair black? Because hair absorbs all colored lights. Okay, so it appears black. So why does the student's shoe appear white? What does it appear white? Because they don't absorb any color. Okay, the shoe does not absorb any colors. If I don't absorb any color, I will bounce off everything. I will see white. White is when all colors are present. All right. Guys, are you okay here? Are you okay so far? I hope you are. This color part is a bit hard, I understand. Okay, but it's common sense. I don't know, for me at least. It's kind of common sense. Okay, so next. Oh, magnets. Okay, sorry, we have one more chapters to do. I almost forgot. Okay, let's quickly talk about this. Are you okay? Guys, any question about light? Any question about light? Still, guys, focus on reflection and refraction. These are the two main things. Okay, your reflection, bouncing, your refraction, bending. These two are still the bread and butter of this chapter. It's still the most important part. I wouldn't pay too much attention to the color one, unless you have a lot of time to study. Okay, unless you study everything, and then there's nothing else for you to study, then you focus on the color, lor. Focus on the color. Okay, it depends on your school, Depends on your school. Some schools, they don't teach color, some schools, they do. Okay, so depends on your school. Okay, anyway, let's go to magnet, shall we? Let's go to magnet. This is the last chapter and also the easiest chapter. All right, because magnet you already learned in primary school. Okay, so magnets, what are they? So magnetic material can be magnetized and become magnets. Okay, so what is magnetic material? There are only 3 magnetic material in the world. Okay, that would be iron, as in 铁, cobalt, and nickel. These two, they are also elements, right? So only iron, cobalt, and nickel, they can be magnetized. They can be magnetic. Okay, that means, okay, very easy. Guys, if you take a magnet, right? If you take a magnet, a piece of magnet, and you take an iron stick without magnet, without any magnetic effect, you brush against it, they will become magnets, right? But you can never do this to aluminium. If you take a piece of aluminium and you brush it against a magnet, nothing will happen because aluminium is not magnetic. Not magnetic. Right? But iron is magnetic. Iron is magnetic. Cobalt is magnetic. Nickel is magnetic. That's why any metal that has these 3, they will become magnet. Right? Like for example, steel. You know what is steel? Steel is your gang. Okay, gang. So this steel, right, is made from iron. So steel is also magnetic. Right? Because it's made from iron. Okay, so next, magnets show magnetic properties, attracting or repelling other magnetic materials. I'm sure you already know. Okay, let's look at the bottom one. They attract magnetic objects like iron, cobalt, nickel. They have a north and south pole. Guys, every magnet will have north and south pole. Right? So let's say you have a piece of magnet like this. It has north and south pole. Even if you break it half, you will still get something like this. North, south, north, south. Okay? Magnet always have 2 poles. There's no such thing as a magnet with 1 pole. Impossible. So guys, can you see North Pole and South Pole is exactly like Earth? Our Earth has a North Pole, right? Our Earth has a South Pole, right? You know why? Because Earth is a magnet. Earth is a big magnet. Okay, because inside Earth is mainly iron here. And since iron is magnetic, so our Earth becomes magnetic too. And this magnetic field, guys, this magnetic field is actually quite important to protect us from something called solar flare. Guys, do you know what is solar flare? Do you know what is solar flare? If today the sun goes crazy and decides to shoot out a bunch of radiation to us, that is a solar flare. And then our magnetic field is shielding us from it so that you don't get cancer or any interruption to your radio. Okay, so it shows the north-south pole direction when hung freely with a string. Same poles repel while opposite poles attract. I think this one you already know. 同极相斥，一极相系. Very easy. South-north, they will absorb. They will attract. South-south repel. North-north repel. Okay, as in boy push each other away. Girl also push each other away. But girl boy then they get together. This is how a magnet works, right? This is how a magnet works. Okay, so same poles repel, opposite poles attract. There are two types of magnet, permanent magnet and electromagnet. Okay, this is our focus for today. What is a permanent magnet? A permanent magnet is a magnet like this, like your fridge magnet. They cannot be switched off, right? You cannot control them. They will lose charge over time. They will lose the magnetism over time, but it's going to be really slow. Okay, it's going to be really slow. So that's going to be your permanent magnet. Electromagnet is when we use electricity to go around a coil, okay, to go around a rod and make it electromagnet. Okay, because when you switch it on, when electric current flows through it, it becomes a magnet. When you switch it off, this thing will stop flowing, then it becomes a non-magnet. Am I making sense here, guys? Am I making sense here? This part is really easy, huh? So let's look at your magnetic field. Let's get magnetic field. So two interacting magnets will produce a magnetic force, which is a push or a pull that is produced when magnetic fields are brought closer. Okay, that means they will fight. They will fight. So the magnetic field is the area where the force of magnetism act on another magnet is a magnetic object. Okay, guys, which part do you think is the strongest magnetic field here? Which part is the strongest here? Guys, which part is the strongest here? Hello, don't leave me talking alone. You guys be participative a bit, can? I'm feeling a bit sleepy because you guys are not talking to me. Guys, which part of the magnet is stronger? Which part of the magnet is stronger? Is it the middle or the end? Is it the middle or the end? Are you guys listening? Hello? Hello, don't leave me alone here. Is it okay? Guys, which part of the magnet is stronger? Is it the middle or the end? Hello? Hello? Please answer me. I don't want to talk alone here. Are you guys still there, or am I just talking to myself? So yes, the north and the south pole, correct? Correct? Yes. Thank you, Yunki. Hey guys, you won't lose a piece of meat when you talk, right? 你不会少一块肉的。哎呦。You know what? You know why am I always Monday that sleepy? Because you guys are not talking to me. I'm talking alone here. Hello, don't do this to me. Okay, so your north pole and the south pole is the strongest. North pole and south pole is the strongest. You see how much iron they are attracting. So north pole and south pole is the strongest. You see the middle here is only a bit. It's only a bit here. Okay, so that's your magnetic field, by the way. Oh, by the way, in exam they will ask you to draw this magnetic field. They ask you to draw this magnetic field. Okay, so interacting magnets will produce a magnetic force. Magnetic field is the area where the force of magnetism acts on another magnet or magnetic object. Okay, so magnetic field is when you can feel the magnetic force. If let's say you're a piece of iron, you can feel something pulling on you, that means you are in a magnetic field. just like this. Okay, guys, learn how to draw this magnetic field. Can you see north going out? Okay, north is going out, south is going in. So draw 3 lines, 3 lines. And then the remaining 3 lines is when you loop over, because north will go out, south will go in. So they loop over, they loop over, they loop over. Okay, please draw one more for me, if you can. Okay, it goes from north to south. All right, north to south. This is our magnetic field. Okay, guys, can you see the arrow here? Can you see the arrow? Pay attention to the arrow. Can you see north is going out, south is going in, and then it will go out from north and go back to south. When you put a compass, this is where they will ask you to draw an exam. When you put a compass, the compass will just follow the arrow. Can you see? So wherever you put, let's say you put it here, it will go here. It will follow the magnetic field line. Okay, it will follow the magnetic field line. So the arrow is just pointing just like what you draw. Easy, huh? Easy, huh? There's no calculation here, no nothing. It's just you drawing the compass. Right? So what about Earth's magnetic field? The Earth's core is made from iron and nickel. Like I said, iron and nickel, they are magnetic. Okay, which makes the whole Earth magnetic. Iron and nickel is magnetic. It is divided into 2 parts, the inner core and the solid metal. Okay, and the outer core, which is made of liquid metal. Okay, this is not important, but basically it's a spinning metal ball. Our Earth is a spinning iron and nickel ball. That's why we have our own magnetic field. All right. As the Earth spins, the 2 parts of the core move at different speed, and this generates a magnetic field. So you have a magnetic field here. And Earth's magnetic field shields us from dangerous cosmic ray and solar wind. Now, what is a cosmic ray? Radiation from outer space is cosmic ray. Guys, if you go become an astronaut today, if you live in space, you're actually getting more radiation than normal people on Earth. Right? Because our Earth, we have atmosphere protecting us. If you're outside into space already, of course, there's less UV protection. Okay, so you get all these radiation. So cosmic ray, then your solar wind. The solar wind is coming like this. Is there a picture here? Okay, not really. So this is your so this is your magnetic field. Okay, so it protects us. Our Earth's magnetic field is actually very important. So let's talk about electromagnet. Okay, now we want a magnet that can switch on and switch off every time. Right, for example, do you know what is this? Do you know your access door? You know your access door? When your access door, when this thing switch on, they become magnet, they will stick. When you key in the password or when you press a remote, this thing will switch off for maybe a few moments, and now you can open your door. Right? This thing is an electromagnet because it uses electricity to become a magnet. And it's a temporary thing. You switch off, no more. You switch on, there it is again. It's not like a permanent magnet. Permanent magnet is like constantly on one. All right. So permanent magnets are always magnetic. An electromagnet works using electricity and it can be switched on or off. Yeah, good thing. An electromagnet is made up of a coil of wires surrounding a piece of iron. Okay, so you have a wire here, you have a piece of iron here. Okay, so it will become magnet when you give it electricity. When a current flows through the coil, magnetism is induced in the iron, while the coil and the iron forms a strong electromagnet. So this is going to form a strong magnet. Okay, so when the current is switched off, the electromagnet loses its magnetism. Okay, when there's no electricity, there will be no magnet. Right? Of course, you switch it on, there it comes again. Okay, so the strength of electromagnet, how do you make this thing stronger? Let's say now this can only absorb 3 paper pin. Now I want to absorb like 7. So how do you make it stronger? Number 1, you increase the number of turns. You make more turns, they get stronger. The diameter, okay, make the wire bigger instead of smaller. Soft iron core, pure iron is used. Okay, usually inside an electromagnet. Okay, it is made using pure iron, as in the element iron. And electric current, if you make this thing higher current, let's say from 3A to 10A, you will definitely feel a difference. Right? You will definitely feel the difference. Okay, simple. Let's look at the application. Where do we use magnet and electromagnet? Okay, so compass, they use magnet because compass you cannot switch off. Credit cards and debit cards. You know your credit debit card? You know credit debit card? Okay, I don't have a picture here. You know, whenever you look at your mom's or your dad's credit card, behind there there's a black stripe. The black stripe inside is actually magnet. The magnet protects not say protect. The magnet stores your information. What's your bank account? They will store it inside that black color strip there, right? They have an electromagnetic strip, that stores information. Okay, so the magnetic lock on doors uses an electromagnet to lock the door automatically. So yes, it is. This is a temporary magnet. Okay, the temporary magnet. So where were we? Okay, so let's look at number 4. When a current flows through the coil, magnetism is induced in the iron and the coil and form a strong electromagnet. So you have to use soft iron, guys. You have to use pure iron. If you use any other else, the thing wouldn't work so well. Not saying that it won't work, but it wouldn't work that well. Okay, so next, electromagnet is attached to a forklift, okay, to move metal objects, okay, like this thing. When I switch on, this thing will become magnet. It will suck all the scraps. When I switch it off, this thing will immediately lose the magnet and it will drop. Okay, so this electric bell, I don't want to say already lah. You can read this yourself. I don't really care. Okay, so guys, can we do some exercise before we sign off? Okay, can you please do question 1 and question 2 and question 3? Okay, these 3 questions here. I'll go to the toilet real quick. Okay, and I'll give you a few minutes to do. Okay, I'll see you soon. Okay, guys, here comes the answer. I hope you are done. Right, so number 1, this is a north and a south magnet. Explain how can you use the first bar magnet to determine the poles for the bar magnet 2. Okay, how can I know X whether it's north or south? Very simple. I just put my north here. If this magnet goes away, this is a north. If this magnet sticks here, it's a south. All right, so put the north pole of bar magnet 1 to X. Okay, if bar magnet 2 repels, X is north. Okay, if bar magnet 2 attracts, X is south. Then let's add one more point. Y is the opposite pole of X. So if X is a north, then Y is a south, and vice versa. Okay, the other way. Next, relationship between strength and line. So the stronger the magnetic field, the more lines of the magnetic field. More line means stronger. If it's a very big magnet, you'll see many lines. Okay, obviously, common sense. Next, C, when you drop this, of course, this will become south, this will become north. Okay, easy peasy. Next, let's look at number 2. So since I say north is going out, you will see an arrow like that. South is going in. And then when they look backwards, you will see the arrow like this. Just follow the magnetic field line. Okay, so B shows the pattern when I'm following a sprinkle region when the strength is the highest. The strongest is at the pole here. So it should be A. Give a reason because it is close to North Pole. Okay, closest to the pole. No matter south or north, as long as it's close, then you have strong magnetic force. So as you can see here, if I'm close to the pins, I can attract more. Far means I cannot attract. Compare the strength of P and Q. So strength of P is stronger than Q because P is closer. Relationship between strength and distance. Okay, so the nearer the magnet, the stronger the force. The stronger the magnetic force. Okay, next, number 3. So as you can see, there are two magnets, two factors for your electromagnet. You have your current. Okay, so the higher the current, the higher the force. And next, you have your number of loops. Okay, you put more loops, more diameter means stronger. So factor 1 is your current. Factor 2 is your number of coil. Okay, number of coil. Relationship and the field strength. Okay, the higher the current, the higher the strength. Okay, so the higher the number, the higher the strength also. Okay, easy. Next, number 4, let's finish this. So this is to lift up scrap metal. Explain how the crane functions. Okay, so when current flows through, okay, when the current goes through this thing, when current flows through, the electromagnet is magnetized. Okay, magnetized means they become charged. They have they become magnet now. Okay, so it will attract the scrap metal. Okay, so when switched off, the electromagnet is demagnetized. So the scrap metal drops. Okay, switch on means it's magnet. It is a magnet. So switch off means no more magnet. Okay, so that's it for our magnet. Okay, very easy chapter. I can finish this in like a few minutes. Okay, hope you're okay with this. So guys, that wraps up all our syllabus. That wraps up our year 8. So next week onward, we shall begin with our revision. Okay, I hope you receive your August notes already. Your August notes is a revision note. We will start from biology revision. Okay, we'll start from biology revision. Okay, so if you have no question, do you have any question? So you guys being quiet means you have no question, I assume. All right, so if you have no question, then I will call it a day lah. Right, so guys, have a good Monday. I will see you next Monday. Okay, so take care. See you. Good night. Bye-bye.